Okay, let's talk about interfaces. In Java, interfaces are useful when we want to define that something supports a bunch of different methods. They are similar to a class, but we can only declare which methods they support, and we weren't even able to declare default implementation of those methods. So let's see an example. Imagine that we want to declare some kind of geometry program, and I'm simplifying the example that I have in the notes. Imagine that we want to have some sort of geometry program, and we want things to have area. So we could have a class rectangle has int width and height. Let's make this private just for fun. We'll define a constructor. And let's make this floats or doubles. Distance width equals width. Distance height equals height. Right, so that's kind of our standard constructor, and then public double get area. And we are gonna return width times height. Life is good, right? The only important thing is gonna be this, right? We can have a circle class that's gonna have kind of the same thing. It's gonna have double radius. Let's make this actually private. And we'll have a constructor. Let me use the standard. This dot radius equals radius. And then let's define get area again. Not width times height. This is pi r squared, right? So let's use math.pi times radius, right? Now, with this, we could have variables in our main, public static void main in string args. And we could define circle C equals new circle of 3 and rectangle R equals new rectangle, say 3 by 4. What is it complaining about? Oh, I need to make this static. I'm making them static classes just so I can put them in the same file. In fact, normally you would put them in different files, but I want to make this as simple as possible. Now, if you notice, both of these guys have this in common, right? It's the same method, but I cannot express that commonality or make use of that commonality here. Now, we can define an interface. Let's say shape. And what I'm going to define is this has a getArea method that takes no parameters and returns a double. So now that would allow me to take advantage of that commonality. Both of these guys will have the method. Now, on my classes, notice that on the interface, I don't need to declare public. Every method is public, always. Because that's the point, to declare the public interface of a set of classes. So here, I need to say this class implements that interface. So I'll do the same here in my circle. Now that would allow me to do here interface, or sorry, shape s. And I'm just declaring, because I just care about the fact that it's a shape, that I'm declaring my variable as a shape rather than as a circle or a rectangle. I can use that getArea method of my variable s. Because I declared that it's a shape, so Java knows that it has getArea, right? I could actually do s equals new rectangle of 3, 4, and then I could repeat this thing, and it would be calling the right getArea method of the right class. So this would actually print something like 27.5 or something like that, and this would print 12. Let's actually run it and see that I didn't lie to you guys too much. Oh, it was 28. But other than that, it's not too big of a lie, right? So that is the main idea of interfaces. There's a couple of things. First of all, if I didn't have this thing, right, Java is gonna generate a compiler error and tell me where are my errors. You are saying that to implement that you implement getArea here, and then you're not implementing it. So that is one thing. Another thing that we may want to do is to use @override. And this is to tell the Java compiler, hey compiler, I think that this should be coming from some other interface. And so the Java compiler will again complain if that is not true. So this would work, right? Because those are the methods we are overriding. But if we were to put @override here, which is a constructor, it's complaining, it's telling me, well, in this case I cannot put @override that, but I could have a different method, @override public void do stuff, and it's going to tell me you are telling me that you override somebody else, and that is not true. So that's kind of an extra check that we can do on when we are declaring methods that should override methods from a superclass or an interface. We could extend more than one interface, and we'll see that we can also extend a class, and that interfaces can extend from each other. Now, a couple of things. Just like we can declare variables of a given type, we can declare functions that take a parameter of an interface type. So let me do public static print area shape s. And so we can do system.out.println s.getArea. And I need to define what we return. And I could call print area with a rectangle or a circle or whatever, as long as it is a shape, as long as it is something that declares that it is a shape, so it has get area. I can also create arrays of shapes, so I can do shape as array equals, and in here I can put either circles or rectangles or both, right? So I can do new circle of 4, let's use something different than 3, right? New rectangle of 3 and 5, and so on. And it should be separating with commas, not semicolons, right? Now that's my variable s, or maybe better name, let's use shapes. And so I could now do stuff like this for shape as in shapes system.out.println s.getArea. And this would actually work, and this enables me to express that commonality for get area. So a shape is something that has a get area, and then make use of that commonality